Complex numbers are a combination of real and imaginary numbers. In order to write it in what's called standard form, you should always do the real number first and then the imaginary number second. This is a plus bi, where a is the real part. B is also a real number, but it's being multiplied by an I, making it the imaginary part. If you just have a, so if you're not adding an imaginary number to it, that's just a real number. If you have no real number and it's just something like bi, that would be a pure imaginary number. And then if you have a combination, it would be a complex number. So real numbers, so just a, could be something like 1, 2, -4, 1/2, square root of 2, anything that doesn't have an I in it, essentially. Pure imaginary numbers could be like 2i, -4i, square root of 3i, something like that. Okay, so it's just the imaginary part. Maybe it's even just I by itself, but you're not adding any real numbers to it. So complex numbers would be like 1 plus 2i, 2 minus 4i, 1/2 plus root 3i, 5 minus I, whatever. It's a combination of real and imaginary. So that's some vocab before we go into today's examples. We're finding, it's called complex zeros or complex solutions, that combination of real and imaginary of quadratic functions. So what we're going to do here is take a look. It's a quadratic. To solve any quadratic equation, you could do the quadratic formula. So negative b plus or minus square root b squared minus 4ac all over 2a. This is in standard form already, so I can tell a is 1, b is -2, c is 5, and I'm just going to plug it in. Negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. If I simplify this, two negatives make a positive, plus or minus square root of. In my calculator, I would put parentheses, -2 squared minus 4 times 1 times 5. When I plug that in, I got a -16 all over 2 times 1, which is 2. So this is quadratic formula like we're used to, except we have the square root of a negative number. So the square root of a negative number is an imaginary unit, and the square root of 16 is 4. So I really have 2 plus or minus 4i over 2. Now, I am supposed to separate my real and imaginary parts, so we do have to break this up and divide each of these by 2. So I'm going to break it apart and say 2 divided by 2 plus or minus 4i divided by 2. And simplify. 2 divided by 2 is 1, plus or minus 4 divided by 2 is 2, and I have that I. So that would be my final answer in standard form. Real part first, imaginary part second. Let's do this one. Already in standard form, so A is 1, B is 10, C is 35. I'm going to go ahead and plug it into quadratic formula, negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. And then I'm going to simplify, plugging in only what's underneath the radicals, so 10 squared minus 4 times 1 times 35, I got a -40 over 2 times 1, which is 2. Now, I do have that square root of -40. Square root of -40 is actually equivalent to 40i, the square root of 40i. 40 is not a perfect square, but I could rewrite it as 4 times 10. It does have a perfect square in its list of factors. The square root of 4 is 2. The square root of 10 does not simplify. So I'm going to go ahead and rewrite it as -10 plus or minus 2 root 10i over 2. Now, because we need to write it in standard form, separating the real part from the imaginary part, I do need to break it apart, dividing 10 by 2 and that 2 root 10 by 2. So -10 divided by 2 is -5, plus or minus. Here the 2's cancel, so root 10i is what I'd get. I'm going to leave the try problems for you. When you're done attempting it, though, just so you know, what you would get is -2 plus or minus 3i. And then for the second one, you would get 4 plus or minus root 2i.